Hello, today we will learn more about classes continued from the last lecture. Let's create a rectangle class that can represent a rectangle that exists in a Cartesian plane coordinate system. First, let's create three attributes. Pos is a tuple xy that indicates the coordinates of the top left vertex of a rectangle in the coordinate plane. Width means the width of the rectangle, and height means the height of the rectangle. Now, with this class, we can create a new rectangular instance. The myRect instance shown in the slide is a rectangle with the top left vertex at coordinates 0, 0, with a width of 10 and a height of 5. As we learned in the previous lesson, class is a mutable data type. Therefore, it is possible to change the value of any attribute of a class instance. For example, you can see that the height attribute of the myRect instance can be changed. And since class instance is a mutable data type, when it is passed as an argument to a function, the address of class instance is passed to the parameter variable. Therefore, the class instance outside the function can be modified inside the function. Class, which is a mutable data type like list, refers to the same address when you assign a variable to another variable. This is called aliasing. If you want to create two variables with the same value, you must initialize the class instance with the same attribute values. Let's implement additional methods in the rectangle class we created earlier. The area method returns the area of the rectangle, and the parameter method returns the parameter of the rectangle. The movePos method changes the position of the rectangle's top left corner to the given new x and y values. The larger than method returns true when the area of self is larger than the area of the rectangle instance given as other. Otherwise, it returns false. For example, we can implement the methods like this. This time, let's create a square class. However, since the square is kind of a rectangle, many parts of rectangle class can be reused. In Python, a feature called inheritance is provided so that any class can be reused to implement a new class. Inheritance refers to copying and using the attributes and methods of any class. For example, when there is a class called square that inherits the class rectangle, square basically retains the attributes and methods existing in rectangle. In this case, the parent class is also called a superclass, and the child class is also called a subclass. When we want to define a class that inherits another class, we should open parentheses after the name of the child class and write the name of the parent class and close the parentheses. Here, the pass keyword is a keyword with the meaning of doing nothing and is used when not implementing any additional methods in the child class. Generally, the reason to create a child class is to create a new class that has some difference with the parent class. Therefore, there may be differences in some attributes and methods. For example, we might implement a method of a parent in a different way. This is called overriding in Python. Overriding is implementing a method of a child class differently. Methods that are not overridden use the methods of the parent class, and methods newly implemented with the same method name in the child class operate as defined in the child class. For example, let's look at the process of overriding the initializer of the parent class when the class called square inherits the rectangle class. Using the super function, we can call the method of the parent class from the child class. Since all sides of a square have the same length, let's change the parameter of the initializer of the square class to length. First, after inheriting the rectangle class, change the parameter of the initializer. After that, if you want to initialize the class using the method of the parent class, call the initializer of the parent class through the super function. At this point, width and height are both the same as length value. So by passing length as an argument, we can override the initializer of the square class. Let's use the implemented square class. Unlike rectangle, we can initialize width and height attributes of square class by passing only the length as an argument to the initializer of the superclass rectangle. If we call other methods that are not overridden, it works without an error. This is because when we initialize the square class, the width and height attributes are initialized in the overridden initializer. Now, let's create another class. Implement a class called person with the name, age attributes, and introduce and string methods. For example, we can implement a class like this. You do not need to use string formatting to implement your own string method. Now, using the class person, we will implement child classes called student and teacher. Student and teacher have additional attributes in addition to the attributes of person class. Implement student and teacher classes with the new attributes in the slide. We can extend the person class and implement both classes as follows. Python supports a feature called operator overloading that allows any class type to utilize operators. In the previous lesson, we learned that we can concatenate strings using the plus operator. Similarly, some operations can be performed between class instances using operators. Not all operators can be used, and there are a few operators that can be overloaded. Now, let's see how we can use these operators. Try running the following code. The add method is a method that can be defined in any class and allows programmers to use plus operator between two instances belonging to a certain class. However, if the add method is not defined, the plus operator cannot be used, and this add function must return some value. For example, the point class shown in the slide returns a new point instance, assuming that another instance is passed to other. You can think of a plus b on the slide as a.addb. Therefore, 4 is stored in attribute x of c, and 7 is stored in attribute y. The minus operator can also be utilized by defining a method called sub. For example, if we define the sub method as shown in the slide, we can write the code b minus a. Like the add method, this method must return a value. A method called rmul is the method that defines an operation that multiplies a number with a certain class instance. Note that scalar is a number, not a class instance. For example, in the code shown in the slide, if the number 2 is multiplied before the instance called b, 2 is entered as an argument to the scalar parameter. So attribute x of b becomes 2 after 2 times b is executed. And attribute y becomes 4. This time, unlike the code in the previous slide, put 2 after the instance and run the program. When we run the program, we can see that an error occurs. It is very difficult to understand why. If you want to multiply a number by a class instance, just remember not to put the number after the class instance. If you want to multiply 2 class instances, you need to define a mul method. If we define the multiplication method as shown in the slide, we can see that c becomes 19 because of the return expression in the multiplication method. In general, it takes a lot of experience and knowledge to make good use of inheritance, overriding, and operator overloading. Misuse of these features can lead to many bugs in your code or poor readability. So, if you're not confident enough to take advantage of these features, it's better not to use them. Let's talk more about how to make your code more readable. The following are things to keep in mind when programming. First, the variable name should be easily recognized. It is better to set the role of a certain variable as a variable name. If you continue to study programming or develop software used in industry, the length of code you need to write or modify becomes very long. As the code becomes longer, it is important to improve the readability of the code. Code that is difficult to understand the purpose of variable is often difficult to understand not only for others but also for the original writer. Therefore, it is better to set variable names in a form that clearly states their use instead of variable names that cannot be understood, such as A, B, and C. Also, when writing a loop, it is recommended not to write deeply nested loops more than triple nested. If you need to keep creating the loop inside, you can improve the readability of the code by implementing the inner loop in a separate function and calling it in the outer loop. Likewise, deeply nested conditional statements also hurts the readability of the code. Thus, you can improve the readability of the code by implementing the inner conditional statement in a separate function and calling it in the outer conditional statement. It is recommended to write a short function. It's a good idea to write a function simply and make it do one small task. Like variable names, function names should be easy to understand. Of course, the same goes for classes. Like we said for functions, it's also a good idea to make sure that one code file isn't too long. If the code becomes too long, the code file should be divided. You will learn this method in the last lecture. Now, let's solve a practice problem. Let's implement a class called College Student, a child class of the person class that we implemented earlier. In addition to the inherited attributes, additionally make the year of graduation, major, and GPA as attributes. And try implementing it by overriding the string method. We can create a class called College Student by inheriting the person class as follows. In the case of string method, you can implement it in a different way. This is end of today's class. Next class, we will learn about dictionaries.